Okay, guys, this is the closing talk for this track for today. I'm going to talk about man-in-the-middle attacks on publicly switched telephone network. So me and some friends, some colleagues that helped me with the research discovered some new attacks, new methods. But I should note that this presentation does not include any new vulnerabilities. We just combined existing ones to make some novel attacks. Now, just a little bit about myself first. My name is Kirils Solovjovs, and I work, play, and talk. In work, I'm an owner and hacker at a company called Possible Security. We just celebrated 10 years a week ago, so that's a milestone, I guess. I'm also a research assistant at the Institute of Electronics and Computer Science in Latvia, and this research here is kind of a collab between the two spaces that I'm in. Now, I'm also known as destroyer of e-signatures. Couple years ago, I published a small white paper about how all e-signatures in all the countries in Europe and indeed the world are insecure. Before publishing, we talked to some governments, and no one knows how to fix it, unfortunately, so I just went ahead and published it. I'm also author of RouterOS jailbreaks, which has helped many researchers, some of them in the US and internationally, to discover further bugs in microtic RouterOS operating system. And I talk a lot. So I've been to Nullcon before. I've talked to CCC, Hack in the Box, Hackfest, and so on. So today, and you can follow me at Chaos Social if you want. I talked with some people before the talk. Apparently in India, not many people use Mastodon yet. In Europe, we're really mad at Elon Musk for ruining Twitter, so we all moved over there. So the register is quite easy, like getting an email. So you register, you can follow me. Anyway, so today we're going to be talking about what PSTN is, what mobile networks are, just a bit about social engineering, and of course we're going to take a look at some attacks. We're going to take a look at the two new attacks we developed and two tactics that can be used to apply those attacks in real life. Now, how many of you have heard of PSTN? One third to one half. Okay, so the rest of you, welcome. I'm going to give a short intro. So it's public switch telephone network. It's a technology of past century. I think it's more than 50 years old, but it's everywhere. It's worldwide. So basically, this is this separate network of wires, a bit virtualized these days, to be fair, going all over the world that allows us to call each other, right? And it includes both physical, hardwired telephones, and of course mobile networks, mobile telephones as well. The interesting part about it is that it has single global address space of phone numbers. Like here in India, for example, all your phone numbers start with 91. Which is the country code. It's known as country code for India. Numbering scheme is defined by standard E.164, but the most important part, I think, is that PSTN is really, really old school, and what is less well known, we still use it. Even mobile networks are part of PSTN. Now, when researching PSTN security, I found a chart online at some company's webpage. You can see the reference on the screen that compared PSTN to voice over IP. And so what caught my eye is the question, is PSTN secure? And their answer is, yeah, it's highly secure because it has dedicated lines, which, you know, in a way, it can be true. While attacking phone on the wire is trivial itself. As soon as you get to the wire, it's unencrypted, the original standard, right? But it is very restrictive geographically. You have to physically go to where the wire is. You can't just hack it over the internet. If we contrast it with voice over IP, of course you can hack it remotely. Now, here today I will be presenting attacks that work literally from anywhere in the world. And that's the power of these attacks, I think. So, before we will end the presentation with the attacks. Before that, I want to build up so that everyone in the audience, even those who have never heard of PSTN before today, understand the parts of the attack. So I'm going to talk about CLIP a bit. It's caller line identification presentation. Now, I've never had a voice number in India, so I'm not sure if someone calls you, you probably see the phone number of the person calling you. Yeah, I see some people agreeing. Was it always that way? Because I remember in Latvia, when we moved from 1G, which was analog telephones, analog mobile telephones, like radio stations basically, to 2G, clip came in, but you had to pay for it. You had to pay like €5 per month, which is I think around 40 rupees per month, just to see the number of people calling you. And it's kind of similar to what Elon Musk did with Twitter, right? So now you have to be a subscriber to get this unsecure feature of second factor over SMS. And it's the same we had back then for Clip. You paid some money, you got info on who was calling you. Problem with Clip, of course, is that it's always been insecure. It can always be spoofed. Now, in the next slide, I'm gonna show you the first small demo. There will be two phones on the table. And the demos are, lots of the screens blurred, but that is mainly to protect phone numbers, server addresses, and API endpoints that we use in the demos, right? You will see the important bits, I believe. Now, you will see just a normal call via Clip. Important fact that phone book is used. Now, we have a phone that is registered as John Doe on the left of your screen, and we have a phone that's registered as super secret project employee on the right. So we just wrote in the phone numbers in the phone books of each phone, so nothing special. And we can see that one phone is calling the other phone and it behaves as expected. We see the caller ID with the phone number, which is blurred, and the phone book entry on the screen, right? This is Clip. So United States also has something else. United States also has CNAM. I'm not sure. I don't think anyone else has it in the world, so India probably doesn't have it. CNAM is caller name delivery, which is one step further. So if the number is not in your phone book, the operator can send you text along with the number. Similar to how when you spoof SMS, you can spoof not only number, you can also spoof some source address as a text that is coming from. Now, CNAM allows that for phone calls as well, and it's an US feature, right? Now, there's also CLIR, caller line identification restriction, which basically makes your phone inform the operator that you would like your Clip information to not be sent or to be censored. I use CLIR a lot, mainly because I have blocked all the incoming phones to my number, and I don't want people to get confused. If I call them, I get a missed call, they will not be able to reach me anyway. So I use CLIR, and it shows like no number when I try to call someone. Now, CLIR by itself is not foolproof, of course, because there are multiple places in the metadata where your phone number, or rather your MSISDN, is implanted, and CLIR only clears one of those. So yeah, but still, it can be used, of course. Now, in the next video here, you're going to see the standard spoofing attack. Both phones are on the table, but John's phone on the left receives a call from super secret project employee on the right. And phone on the right knows nothing about it. Here we use a computer, basically voice over IP client that connects to a trunk port, and we've configured the number to be spoofed. Now, I want to be clear, this has nothing to do with local wireless communication. This is all over the actual big mobile phone network, the attack performed here, the demo performed here. Okay, next component of the attack, signaling system 7. How many of you have heard of that, SS7? How many of you could explain what that is? Okay, good. We still have 10 hands up at the explanation point. That's good. Okay, so signaling system 7 is a separate network between all the phone providers. So basically it interconnects the PSTN. All the providers, both mobile providers, non-mobile providers, virtual providers, most of them have access to SS7, and it's crucial up until 3G, including 3G, if we talk about mobile networks, for different stuff, like setup and tear down circuits. Circuit is a fancy name that they use in the specification for a call. So basically, if you want to create a call before you actually can send voice data, you have to use, your operator has to use SS7 to set up the connection to the other operator. Your phone does not speak SS7. It's all managed by the operator. It also handles number translation, prepaid billing, which is quite important, right? If I travel abroad and I'm on a contract, on a postpaid billing, that's okay, because the phone company has my home address and my signature and everything. They can ask for the money of me later. But if I'm on prepaid, I'm anonymous, I've paid like 10 euros for a card, it would be really, really important for them to stop my service even being in India when I run out of credit back home. So prepaid billing is also one of the many things managed by SS7. And what's more important for our attack here, SS7 also manages diversion. So for example, if you take your phone out and you type *21* and a phone number and then a hash sign or pound sign and press call, your phone will request all the incoming calls to be redirected to the phone number that you enter, right? For those of you that want to experiment, it was *21* phone number hash sign. And you can cancel it as well, but I'm not going to tell you how. You can Google it. And it happens through SS7. And that's important. That basically means that if we have access to SS7, we can ask the operator to do the diversion for us. SS7 manages a bunch of other stuff. There are tons of attacks. I think the most prolific hacker that has worked with hacking SS7 and publishing his research is Carsten Knoll of SR Labs. You can look up his presentations. Those are quite cool. Now, the final component of the attack is, of course, social engineering. This is not a talk about social engineering, so I'm just going to briefly mention the definition. Listen carefully. So basically, social engineering, for those of you who don't know, is a method of making sure that someone does something that they're not supposed to do, or reveals some information to you that they're supposed to keep secret, right? Those are the goals of social engineering, and there are multiple ways to do it, right? Just asking for a favor is also a basic level of social engineering, right? This is a private party. Can I get in? Sure, okay, you're in. You're a social engineer. But there are different levels, and the attacks can be more complex, and we're going to see this in use in one of our attacks. Now, and mobile networks, as I mentioned, of course, are also part of PSTN. They have additional problems as well. For example, A51, the secure encryption that was originally created for the partner countries has been broken for years. A53 is a bit better, right? But there is no mutual authentication on the air interface for 2G communication. So basically, your phone will connect to any network that knows the secret code, and then the network will only let in the phone that has the I key, which is quite long, relatively long, right? But the secret code is 5 digits. So, for example, for the largest mobile operator in Latvia, that's 24701, and the lists are public, obviously. This allows us to create fake BTS, also known as IMSI catchers, that on a downgrade from 4G would allow us to actually not only intercept phone calls, but also do some more simplistic attacks. Now, the difference between the attacks we present here and the fake BTS is that fake BTS is geo-restrictive. So we set up a station, and it works like half a kilometer, maybe more, around the station. This attack works worldwide, wherever you are. Right. Okay. So, tactic 1, intercepting phone calls. How can we intercept the phone calls? And I'll just mention that there's an address on the left of the slide. The old version of the slides is there already. You can download, you can take a look, and the new one will be there in a couple of days as well. But if you want, you can of course take photos. Okay, so interception of phone calls. The first attack we present is simultaneous ring attack. I'm going to show you a video. And before that, I'm just going to tell you that the audio that you hear is the one that is intercepted at the man-in-the-middle position, right? So that's where the audio is coming from. But the video signal itself is mixed between different sources.
Which one? The one with the secret password. Can you give it to me? Yeah, uppercase QWERC. Excellent. So, the business is very secret, so
Right. So, there you go. Phone call over the public telephone network, specifically mobile network, in this case between two different mobile networks actually, and a computer in different place could or was able to record the audio of that. Now, this doesn't tell much about how it's done specifically, but I'm going to have one more video regarding that answers that question, and I'm going to have a schematic for you as well. So basically what happens here is that both parties are simultaneously calling each other. So on each phone they see that the other person is calling them. And our research, limited research at this point, but it indicates that if the victims were in fact planning a phone call on that day, the confusion on who called who quickly dissipates, as you saw in the video. Right? Yeah, you're calling me, I'm calling you, whatever, let's talk about business. So that's the strategy here, basically. And what happened with the phones is visible here. So once again, we have both phones down on the table, and from the laptop we initiate these two calls. This is the first step of the previous stack that you saw, and both phones are calling each other at the same time. This is how it looks visually then, right? They're untouched on the table, calling each other. Now, here's the schematic of the attack right here. It's a simultaneous running attack. So basically, the components we have. So we have the PSTN or mobile network on the top. We have voice over IP layer, and we of course have our audio capture setup, if we can call it that way. And I used the red circles with digits in them to mark the steps of the attack. This attack is quite simple. So basically, all we do is we take our voice over IP devices, which are connected via a trunk to a voice over IP gateway. That connection is one of the multiple ways that you can spoof phone numbers. One device calls device A pretending to be device B. The other device simultaneously calls device B pretending to be device A. When they pick up, the green lines on the bottom are connected via audio, like you can use, for example, Jack on Linux to do that. And they're basically patched through, so B to A and A to B. And while we're at it, we also tap it and record both of the streams that are happening there. So that's basically that. Let's move on to attack 2. Diversion attack. Now, you're going to see a video where one victim receives a call from the other one, and the call then gets redirected, intercepted, and then forwarded. In this scenario, one person is legitimately calling the other, and the other is receiving a call. There we go. This person is calling someone. And once again, audio is, of course, from the capture device.
Hello? Hello. This is a parcel service. You have a delivery for pickup at 1 o'clock in Freedom Square. Your secret PIN is 53896. Will you collect it on time? Thank you. Oh, excellent. Bye-bye.
Now, in this demo, we simulate a scenario where the persons don't know each other. And we have a parcel delivery simulation here where a parcel delivery person is calling customer on their real phone number, right? Also, the sounds you heard at the very beginning, those are the ones on the recording device. The actual delivery person heard relatively normal beeps while the other person was picking up. Right, this is how it looks here. The diversion attack. It's a bit more complicated. So one of the many ways to do the diversion attack is to employ SS7. The first step, once again, we have the digits, the step numbers in the red circles over there. Is you can use SS7 gateway to request a divert from a specific phone number to one of our phone numbers. So the difference here is that for voice over IP devices, we do have to have an actual external phone number for one of the devices, right? And that's what we do. We basically register with SS7 that when a phone call is coming into B, it should be redirected to number E. And then it gets redirected via PSTN to our voice over IP provider, via the gateway to our voice over IP endpoint, the client device, right? That's the first step and the second step. After that happens, step 3, we once again repeat what we've done before. We call from a different voice over IP endpoint, pretending to be user A to user B. Now, how it looks to the users from up there, right? It looks that A is calling B. That's all they know. And B is receiving a phone call from A. So it looks really, really legit, right? And when they pick up, basically, then we once again run the audio through jack, and we tap the audio and record it. And I also missed a bit over here. So the third step is actually we cancel the divert. We cancel the divert so that we can call number B, right? Otherwise, when we call it ourselves, then it will also get redirected and we will not get connected. So before step 4, we actually do step 3 when we cancel the divert. And after we're done tapping, or after the call setup is done, actually, we can send the divert command again, so we don't miss the next call as well. Now, there are other ways to do the diversion. SS7 is, the classic one, but we also looked at some other potential ways that phone diversion can be created. One of them is using ENUM. In the year 2000, RFC 2916 was defined. It was called E164 number and DNS. As the name implies, it basically links the phone number, the global phone number, with the DNS system. What could go wrong? And it's been updated a couple times by RFC 3761, I think, and 6166 in 2011. And it's exactly what it does. It gives information to voice over IP devices how to contact a number over different ways, right? So this is, for example, E164 representation of a phone number. And if a voice over IP device would like to check with ENUM if it's possible to reach these numbers in some other way, they can do a DNS request for record type NAPTR, like this. It goes from the right to the left. Why? Because we always have the larger entities on the right for DNS, right? That's why it's reversed. And we get an answer. It can be a different one. For example, this says, okay, so you can reach this number via SIP, which is basically voice over IP. If you connect to voice over IP up.pt and you connect to this username, you send the call request to this username on this host. This is actually real data from the DNS system. The next step is your voice over IP device will look up server record for SIP. It will get some domain name and it will look up a record, of course, and it will get the IP address to connect to, right? And then it will connect over there, send the end user number, and connect the call for you. That's how it works. Now, where's the attack? We can use this by simply changing the first reply. We can, of course, change any of the further replies as well. That's the beauty of DNS. It's recursive usually, so you get multiple attempts. And there are multiple hacks, DNS cache poisoning, and multitude of others that you can use to actually fake the response. Now, if we were to intercept this response and provide a believable reply to this DNS request, DNS query, we'd be able to redirect the phone. Why? Because, well, if you take a closer look at the record that we provide here, it says PSTN : tell, which basically means, hey, so there's the redirect. You have to call this number over the normal channels, not over the internet. And that's a way how you can basically do it. Now, we can, of course, also apply social engineering to facilitate the diversion part. There are multiple ways to do it. We can do physical attacks, right? If we get physical access to the phone, we can do lots of stuff, like, for example, reconfiguring it. You can do this. Just take the phone and call this number, and you have a redirect. You can, of course, use phishing as well. Phishing over voice. Hello, this is Dog. Please call this number to get some money. And you can do classical phishing. Right? You can send an email to someone with this link. They open the link on their device, and the device redirects redirects the phone call for you. On Androids, I think it doesn't allow that, but on iOS, it nicely asks if you're sure, and then you say click yes, and then it happens. So that's quite cool. Right. Then let's talk about tactic 2, alteration of phone calls. We can not only listen to phone calls, but we can, of course, alter them. And it's relatively easily, so it doesn't require any of the hacky stuff. You just change the sound part, the audio part, right? Here's asynchronous substitution. Basically, instead of recording, we change the jack configuration a bit. We use headphones, we use a microphone, and one of the persons gets delay in receiving the information, but it can be different information, and delays often happen over phone calls, especially encrypted phone calls, but why not unencrypted phone calls as well? Now, for this attack to work, it's important that persons don't know each other, because you're going to have different voice on the other end. But if it's a once in a lifetime contact, like a courier, like someone delivering pizza to you, then it will work. The other thing that we need to do, you need to manage your volume, because there may be audio feedback, right? And audio feedback may happen over here, right? Because if the person here uses a speaker at that speakerphone at that time, and you push your audio in too loud, then their microphone will capture what you're telling, and it will get transmitted to this other person, and they will immediately hear that there's a third party on the call. So that's something that has to be taken care of as well. Now, and of course, I had to have a slide with artificial intelligence in it. You can theoretically do this. We haven't done it yet, but it's a theory. It should work. So basically, instead of the microphone, you have an AI, or you use some models from Happy Face, train those, or maybe OpenAI, and it changes on the fly the text that needs to be changed in the audio, and you can just sit passively and listen in as your model does what you programmed it to do. Now, okay, those are the attacks, and I think I'm quite relatively good on time, which is nice. Maybe we'll have a minute or two for questions. Now, my lawyer asked me to include this slide as well. So here it is, proposed solutions. Now, as I mentioned in the beginning, there were no new vulnerabilities. Each one of the problems that I touched upon have been known by the industry for many, many years, tens of years. But we presented some new attacks. I believe that since vulnerabilities have existed for so long, it's really important at this point to educate the general public, because we see some of the combinations that we never think about. We have thought about, and at least in Europe, governments communicate to us about risks of spoofing phone numbers, both for calls and SMS. But risk of interception is not really considered, even though it's really, really real, as we've shown here. Now, but what to do? Is there anything we can do technically? Yes. SS7 firewalls, that's a thing. So basically, even though SS7 is a really open protocol, and originally anyone can do anything, and it was that way because there was a really limited number of phone companies worldwide, and each of them were trusted. So you could just send any garbage you want. You could send interrogate location request, and you get location of a random phone number somewhere in the other end of the world. Now, companies are implementing SS7 firewalls, custom solutions that actually filter some of the commands, so that works. For 4G and 5G connections, the way that your phone connects back to home network when roaming has changed, which has really decreased the role of SS7 and made many of the attacks on SS7 unfeasible, so that's also good. Now, then verification of routed clip, something similar to BCP38 for networks, where you verify that your IP addresses match up with reality and potential space that you have for them. You should also verify the clip that you're routing. Well, but once again, since PSTN is a global system, I don't imagine that all the companies in the world will agree on doing that anytime soon. But we should at least start somewhere, and some European countries actually at the government level have passed laws and changes requiring to grey list some networks that send a lot of fake clip information. Use DNSSEC, of course. ENUM is going out of style. It never really caught on, but still using DNSSEC is a good plan. If you don't use it yet, please do. Does India and TLD support DNSSEC? Anyone knows? Yeah? Okay, so use it, yeah. Latvian TLD also supports DNSSEC, but I don't use it yet. It's too hard. But please use DNSSEC. It's cool. And finally, of course, you can use encrypted communications to communicate. It solves most of these problems, like using Signal or Threema or stuff like that, or even WhatsApp is better than nothing. So those are the solutions. That was my presentation. Thank you so much. Slides are on Kirils.org. You can follow me on chaos.social. My username over there is K. And if we have any time for questions, we can do those. Thank you so much.